Welcome back. Now what we discovered in the previous video is that if you have two radical expressions, they don't have to be alike, they just both have to be radical expressions, you are allowed to simplify them. So when I have the square root of 3 times the square root of 30, that would be the square root of 90. And then if you can, you should simplify further. Can I simplify the square root of 90? Yes, I can. That is going to simplify into 9 times 10 underneath the radical. And if you remember from previous lessons, when we talked about radical expressions, we said, make yourself a list of the perfect squares that might be factors of what is underneath the radical. If you make yourself this list and you refer to it, then you can probably pick out which one of these numbers is a factor of something underneath the radical. In this case, 9 was on that list, so I do 9 times 10. The square root of 9 is 3. And then root 10 remains underneath the radical sign because it can't be simplified any further because it's not a perfect square. When I have root 2 times root 5 times 8, well, 5 times 8 is 40 times another 2 is 80, so this would be the square root of 80. Are any of these numbers perfect squares that are factors of 80? Well, yes, 4 is for sure, but I want to pick out the biggest perfect square that I can, and that happens to be 16. So root 80 is really 16 times 5. The square root of 16 is 4 multiplied by the square root of 5. The square root of negative 12 times the square root of negative 12 would be the square root of negative 144. Now, if this were positive, I would be able to simplify this further. But we learned previously that there are no square roots of negative numbers in our real number system. When you get to Algebra 2, you will learn about imaginary numbers, but not today. What about the square root of x times the square root of x? If I multiply x times x under the radical, I'll get x squared. Now, you may remember from previous lessons that the square and the square root are inverses. So the square root of x squared is just x. Another way to think about it is that you have x squared underneath the radical, and then this square root is the same thing as saying to the 1/2 power. The power to power rule says that you're able to multiply these. 2 times 1/2 is x to the first. And of course, these two things are the same. They're just different ways of thinking about it. What about with division? The same assumption applies. Two radical expressions can be divided. 30 divided by 3 is 10, so root 30 divided by root 3 is root 10. Using my calculator, 1,728 divided by 12 would be then root 144, which of course is 12. The square root of 40 divided by the square root of 2 is the square root of 20. We recognize this as 4 times 5. Of course, 4 is the perfect square. The square root of 4 is 2. We still have root 5. We don't turn this into a decimal. We're looking for exact values here. What about the square root of x divided by the square root of x? Well, that would be the same thing as the square root of x divided by x. X divided by x is 1, and the square root of 1 is 1. But let's think about this in a different way. If I had 3 divided by 3, you would say that that is 1. If I had 100 divided by 100, you would say that is 1. If I have x divided by x, you would say that is 1. So the square root of x divided by the square root of x is 1, because anytime you have the same expression in the numerator and the denominator, the value is 1. We'll summarize in the next video.